So yesterday and the day before yesterday, we had a quiz on what we went over the day before yesterday. Okay? What we talked about the day before yesterday was triangle similarity. And you had to prove that the sides of a triangle were in proportion with another triangle. And if your sides were in proportion, then your two triangles were similar to each other, correct? All right. So today we're going to talk about triangle proportionality theorem. All right? And this is what it is. Okay? I'm going to explain it and then I'm going to show you. And I'm going to explain it with a picture because if I read it to you, you're not going to understand it. Okay? So what the triangle proportionality theorem basically says is this. It says this. If this line and this line are parallel to each other, meaning they don't cross each other. So if this line and this line is parallel to each other, then this segment and this segment will be a ratio, and this segment and this segment make a ratio, and those two ratios will be proportional to one another. Meaning if I take the ratio and I reduce it, I get the same on each side. Okay? So basically what it's saying is this. It's saying that if I take BX and I put it over the same side XA, that is going to be equal to BY over YC. Okay? That's what it's basically saying. So I'll give you for instance. If this was 1 and this was 3 and this was 2 and this was 6, then I would set it up as a ratio or a proportion and I would check it. So 1 over 3 and 2 over 6, they have to equal each other, and we know right now they do equal each other. How do we know that? Because 2 6 reduces to 1/3. Okay? I can also check it by cross multiplying it. 1 times 6 is 6. 3 times 2 is 6. I got 6 on either side. So those two ratios are equal to each other, making a true proportion. Alright? Now, once you have a true proportion on each side, then you can say that XY is parallel to AC. Alright? Now, that sounds complicated, don't it? But it's not complicated. I'm going to read the theorem to you. All right? The triangle proportionality theorem says this. If a line parallel to a side of a triangle, if a line parallel to the side of a triangle, this line right here is parallel to this side of the triangle, intersects the other two sides, so this parallel line right here is parallel to that, and it intersects both sides of the triangle, okay? Then it divides those sides proportionally. So meaning this side and this side are proportional to each other. Okay, that's what it means, all right? Because look, if this line went up here like that and wasn't parallel, would this side be proportional to this side? No, it wouldn't. You'd have a bigger or smaller ratio over here than you would over here. You understand what I'm saying? It's like if I take a cake and cut it in half, and I give you half, and I give me half. How much do you have? 1/2. And I have 1/2. But if I take and I cut that cake a little bit, not in half, who's got more? Either you got more or I got more. We're not ratio. I'm cutting this thing in half, making this side equal to this side. Okay, you understand what I'm saying? All right. Here's what your problems are going to look like today. You're going to have to solve for a missing side. Oh, Lord. Oh, Lord. Better pay attention. Put that phone down. All right. Put that phone down. Okay? So, day before yesterday and yesterday, this is how we would do this. We would say, this is the small triangle. This is the big triangle. We're going to take 20 is to 20 plus x, and we're going to set that equal to small triangle. 18 is to 18 plus 9, which is 27. Now that's some huge numbers to work with. And you cross multiply and you solve for x, and that's a lot of math to deal with, isn't it? Okay? Well, today we don't have to do that because of this theorem. Number one, does this line here, is it parallel to that line? Yes, it is. Does it connect these two sides? Yes, it does. So all I got to do is set up a ratio here, 20 over x, and set a ratio here, 18 over 9, and set them equal to each other. And then I take and I cross multiply to solve it. So what's 18 times x? 18x. Which side does that go on? It does not matter what side that goes on. 18 times x is 18x. Is equal to 20 times 9, which is 180. How do you solve that? You divide. So I divide by 18, and I get x equals 10. So my missing side right here, my missing segment right here is 10. And that's all we do. Okay? And I bet you 100 buckaroos. If you did this right here, I bet you get 10 also. Why would I be willing to rest 100 buckaroos? Because I've already done it. And it gets 10. Okay? All right? Anybody have questions about that problem right there? Okay, Derek, ask. All right, let's move over here. Here we go. All right, we're going to solve for this missing variable right here, x. All right? So we got to set up a ratio, right? So let's set up two ratios. When we set up two ratios, we set them equal to each other, correct? All right, here we go. Y'all help me out. Set me up a ratio on this side.
18 over x.
18 over x, that's fine. Can it be x over 18? Yes, it can. It can be either one. He went from this to this. Y'all remember that. 18 is to x. Perfect. All right? Now set me up a ratio on this side.
24, 27.
All right, there's a problem with that. You went 24 to 27, right? If you went 18 to x up here, you got to go here to here. You see how you went from small to big? You got to go small to big on the other side too. Okay, so I'm going to go 27 is to 24. Okay? All right. Cross multiply. 27 times x is 27x. 18 times 24. Somebody on your handy dandy calculator, tell me what that is. 18 times 24. 432. All right. Divide by 27. And x equals what? 16. So my missing side right there is 16. That's all you're doing. Derek, put your phone up.
Well, you done? I'm listening.
Put your phone up.
I'm okay.
Put your phone up. Don't care where you're at. All right. Now this question is different. Your first 5 questions you got today look like these. Okay, you're solving for a missing segment. That's all you're doing, and that's how you do it. Your last problems are asking you whether or not the two segments are parallel to each other. So in other words, is this parallel to this? And to prove that is parallel to that, I have to show the ratios are equal to each other. Okay? So this is how you're going to do it. Let's go from 21 to 35. That's one ratio, correct? So let's go 21 over 35. Now let's reduce that ratio. What's 21 and 35 got in common?
3 or 5?
7. Okay? Divide each by 7. Divide that by 7. That you get 3/5. Okay? So this ratio right here is 3/5. Okay? Now, for this to be parallel, this side has got to be 3/5 also. Okay, so here we go. We went 21 over 35, so we're gonna go 18 over, what's that? Well, I got 30 of it, and I got 18 there. This whole thing's 30, I got 18 of it. What's that equal to? 12. How did I do that? 30 minus 18 is 12.
Oh, you subtracted?
Yes. Okay, so I got 18 over 12. Reduce that. What's 18, 12? What's the biggest number it's got in common? 6. Divide each by 6. Does that equal that? No. Are those two lines parallel? No. Because that doesn't equal that. Okay? If they did equal each other, your answer would be yes. So somewhere, this line right here is not exactly parallel to this line. Somewhere along the way, it slopes downward or upward and is going to meet that line. That's what that means. Okay?
So the problem is gonna look just